So who can give me their favorite geometry formula?
I really like the Pythagorean theorem. I don't really know many else.
Okay, the Pythagorean theorem works. And what is the Pythagorean theorem, Cece?
A squared plus b squared equals c squared.
And for those who may not yet be familiar with the Pythagorean theorem, or who was long enough ago that they don't totally remember what it is, what does it represent? I saw your head first, Lily.
It's that the shortest side in a right triangle, the two sides of a right triangle that are not the hypotenuse squared, both of them squared, then added will be equal to the square of the hypotenuse.
That is correct. And so on a right triangle, the hypotenuse is always the longest side. It's across from the right angle. The other side sometimes are referred to as the leg. But yes, the sum of the squares of the legs is equal to the square of the hypotenuse. Now, this formula is usually given in this form. But let's say I give you the instruction, solve for A. Okay, and I will say often this is really frustrating to students because we're not solving for the length of A. We're just rewriting this equation effectively so that A is alone. It's not as satisfying as coming up with a numerical answer. But this is what section 1.4 is really about. It's just about reorganizing equations so that we're isolating a particular piece. We might be interested in that piece for some reason. So in this case, if my instruction to you is to solve for A, what do we need to do first? Yeah, we have to, right now this b squared is in the way. We've got to move it. How will we move it, Merlin?
Subtract b squared.
That's right, we subtract b squared from both sides. And so we have a squared equals c squared minus b squared. Now technically at this point, Gino, have we solved for A? No, we haven't. What's the problem? What have we neglected to do? Yeah, this is still squared, and so we've got to solve for A. We've got to take the square root of both sides. And so A is equal to the square root of c squared minus b squared. Okay, so this is what section 1.4 is about. It's really about reorganizing formulas so that you're isolating one particular piece. All right, let's go back to a similar equation. I can't remember exactly what I did, but let's say that I have 3x plus 2 equals 17. So we did something like this. This is like chapter 1.3. This is where we can SAD map. So let's just quickly solve this equation as practice. Gio, what's the first thing that I should do to solve this equation?
Subtract 2.
That's right, we subtract 2. We've got 3x equals 15. And now, Taylor, what do?
Divide by 3.
We divide by 3. And so we have x equals 3. Now let's say that I wanted to graph this on a number line. What would I do? Yes, Taylor?
It's 5.
Oh, you're right, it is 5. 15 divided by 3 is 5. Thank you. Let's say I wanted to graph this, though. Then how would I graph x equals 5?
You put x on the coordinate plane, and it's positive over 5.
That's right, so you guys did some of this with the number lines yesterday. All right, but let's say instead I had 3x plus 2 is less than 17. How would I I'll come back to you, Gio. Is my process of solving this going to be any different from solving it with when it's an equation?
I don't think so, cause like I think you only change like the sign or something when it's like a negative number.
That's right. So in this case, we would still subtract 2. We've got 3x is less than 15. We divide by 3. We have x is less than 5. All right, Lily, you've already had a look at this one. How do I graph on a number line? What does it look like when I do x is less than 5?
X is less than 5. I'm a little rusty, but isn't it, you kind of like make, it's either like you make a line above or below the number line that you like start at 5 and then you make arrows going back less than 5.
That's right. Now, there's just one clarifying point that I will throw to Lily C. So we're going to show an arrow going down this direction, going down from 5, but what do I have to do right at the 5?
A dot with no center.
That's right. So this is going to be an open dot because it's less than 5. And so this is going to go this way. Okay? Now, Gio pointed out something very important, which is a couple of caveats. All right. If it was negative 3x plus 2 is less than 17, I subtract 2, now I have negative 3x is less than 15. When I divide by negative 3, what happens to the inequality sign? It flips around, that's exactly right. So now we're going to have x is greater than negative 5. So this is going to be a very different looking graph. This is going to be an open circle at negative 5. Then we're going to go up the number line. Lily C, when is it a closed dot?
When it is lesser than or greater than and equal to.
That's right. So if this were less than or equal to, less than or equal to, now greater than or equal to, that would mean that we would fill in the stop. Okay? This should be sufficient information to at least get started on the remaining assignments in chapter 1. Our goal today is to be done with chapter 1. That's our target. And then tomorrow we move on to chapter 2. That being said, does anybody have any specific questions for me that you would like to see on the board here at the top?
Not on the board.
Not on the board? Okay, then I can come and answer them separately. Does anybody have any questions that they think would be useful for everybody to see before I send you on your merry way? All right, good luck.